All right, so we're going to start by going over the quiz. Then we're going to talk about the density stuff and then do one more thing. All right, so you just had to tell me. And again, if you wanted to, you could have just done an O, an I, or a P. Cold and Friday, or cold and rainy next Friday. That is a prediction. That is about the future. The dog is hungry. Inference. Why is it an inference and not an observation? Go ahead, Morgan. You cannot read the dog's mind. As much as you know your dog, you do not know what they want when they want it, because the dog can't talk. But I know, and you guys know this, well, like Rufus will walk around whining if he's hungry, like if it's past his dinner time. I have the unfortunate experience to find out he also walks around and whines when he's about to have diarrhea. And I found that out the hard way. So now I have to guess, well, is he hungry or is he about to have diarrhea? So anytime there's emotions or feelings and they're not your own, it's always a guess. And then that makes it an inference. How about the valley was carved by a glacier over 1 million years ago? Inference. Unfortunately, a whole bunch of people put prediction. I know why you did, because you think anytime we start talking about time, it's a prediction, but prediction is only about the future, what is about to happen, or what's going to happen 1 million years from now, not what happened 1 million years ago. So be careful with that. Number 4 is one I bet a bunch of you are thinking about arguing with me about. The class next door is having fun. So it actually came up. So yeah, it is an inference. And weird enough, last period, Mr. Klaus's classroom was so loud that I looked in the hall to see if someone was being murdered. So when I peeked my head out, Mr. Job, of all people, was checking on Mr. Klaus's classroom. And at the same moment, so was Mr. Muha. They were in there squealing. They were having a lot of fun, it turned out. But I honestly could not tell. I even said to my class, I'm like, feel like I need to check on this situation, because I couldn't tell if they were happy screams or like a fight's about to happen screams. It was that bad. I don't know what the heck they were doing. So just because there's sounds that sound like they're happy, could have been Mr. Klaus over there saying, I'm failing anyone who doesn't laugh right now. Or they were actually doing a fun activity. I'm not sure, but it is just a guess. Again, emotions or feelings that are not your own is a guess. Pebble has a diameter of 4 centimeters. Yeah, used a ruler, which is an instrument. And some people wrote inference, I think, because you're getting your I words confused, instrument and inference. But it's not a guess. You were measuring, you knew it was 4 centimeters or 0.4 centimeters. The dog is growling.
I think that could be also an inference.
Why?
Because maybe you can't hear him, but you could like look at the dog from far away and see his teeth. And maybe you're not in like the direction of hearing growl, but you see his teeth barred like that. It could be an inference saying, "Oh, I think." If I erased it and replaced it with an
okay,
O, but you see
that's fine. That's legit. Anybody else? Oh, you want to say the same thing? What were you going to say? The same thing. Tell me in your words, but you were going to say. Okay. So bring your paper up. Anybody else?
We talked about it before class and decided to change it. So.
You can use it for cups and you don't need to use all something. You use one.
Double check in Power School that I changed this. Okay. Because I'm not doing it right this second. You're telling him how to argue. That's the point, is he has to tell me.
Well, he can tell you.
Yeah, but he had to have thought it yesterday when we were taking the quiz. All right, I'm gonna keep going.
Huh?
Yeah. Which one you want to argue about?
6.
6? Why? What'd you put?
I put inference
Okay, why?
because I thought you were looking at the dog
In a picture. Okay. I will admit, I had meant to say you are in the room with all these objects, not just looking at a picture of them. I did mean to say that before the quiz. So that's why I am being so generous now. If I had said that yesterday, you are in the room with all of these objects, I would not have been giving you guys points. But because you have, or at least Gabe, right? Or Gage?
Gabe.
Yes. Gabe came up with it first. Maybe the rest of you are also thinking that. It's hard for me to tell now, but it works. And finally, the liquid is white in color. Again, you were there, you saw it. This one. Sorry, did anybody want to fight that one too? Okay, good. Which terms describe the motion of objects in our solar system that occur in a repeating pattern? That was your giveaway. C. Some repeating pattern is cyclic. And things that are cyclic, if they happen in a cycle, that means they are predictable. So it couldn't have been cyclic and unpredictable. If they're cyclic, they're predictable. Okay, I heard some rumblings about this one. The diagrams below represent different fossils at different locations. When classified by similarity of structure, so structure, like how they're put together or what they're built out of, which fossils should be grouped together? There's a couple ways of going about this, and I have a feeling a bunch of you just tried to look at them and, for example, said that B and D probably went together. That's not the best way to go about answering this. The regents and I will always give you one correct answer. So the best thing I would recommend doing is process of elimination and going down at the bottom. So this is the strategy. This is also, even though I just sound like I'm going over a quiz, right now I am teaching you a test-taking strategy that I think you guys should make sure you learn this year. Use the answers to your advantage. At least eliminate a bunch of possibilities that way. So I went through and I'm like, okay, C, F, J, C, F, J, C, F, and J. Do I see any similarities with them? Yeah, they're kind of all that fan shape. Do I think they're perfectly matched? I would have actually included E in them as well. So I wasn't positive when I was making the answer key if that was the answer. I'm like, okay, they look good. They seem like they match up. Is it the best answer? I'm not sure I'm going to keep going. Then I look B and D, and right away I'm like, oh yeah, this is going to be the winner. But then I get to I. Does B, D, and I go together? No, not that circle shape for all three of them. So that's not it. Cross off the wrong answer. E, G, and H. No. A, F, and H. Nope. So I know I heard one of you guys say 3 of them did go better than everybody else, and that is true. So always use your answers to your advantage and use them to help you get to the answer, not try and guess the answer that way. Students see several classifications should be based on D, observations. Which one of these is most likely an inference? So which one is a guess? That's answer A, that they were transported by a glacier. And they state that they were transported by a stream. This statement is inference. First of all, did I screw up anybody's? Let me make a list. So that was Gage. Nope, Gabe. Gabe. What is it?
Colon.
Why Colden and Addison. Was there anybody else? Okay. All right. I will change your grades. And now I do want to talk about one new thing fairly quickly. So if you could open up, if you haven't already, to page 11, like I had on the board. Rate of change. It's a very small topic that if it shows up on the regions, there'll be one question on the regions, but I do not see this every single year, so I don't want to spend a lot of time on it. It was those noises, just way louder and way scarier sounding at first. Anyway, so rate of change. If I asked you, what is rate?
How something occurs,
Okay, how often? What were you using? You can change the words up a little bit. It was hard. Rate. I know there's another way of explaining it. Like, if I ask you about your heart rate, what does that mean? How fast your heart is going. Yeah, the amount of something over a certain amount of time, is that what you said? Yeah, that's it. It's really, so rate of change, just like your heart rate, what do you think that is? Your heart rate is how fast your heart is beating. What do you think rate of change is? How fast something is changing. Oh, I forgot to put the PowerPoint up. Jeez Louise. My computer is moving in slow motion. I hope that means it's dying and they get me a new one. I want one of the touchscreen ones. Why is this not moving? Come on, move. What's happening? There we go. Oh, look. Oh, it's like duplicating itself. It's totally dying. I'm totally getting a new one. Well, all right, I'm just gonna write these notes on the maybe stop sharing. Oh, that would be so cool if I got a new computer. All right, rate of change, exactly what Morgan said. Right, Morgan? I just said it like I knew it, so it made me question it. How fast a change? How fast something changes, sorry. This is what happens when you don't have your PowerPoint. I still don't think those are the real words I wanted to use, but it's all right. How fast something changes. Hey, that's exactly what I wanted to use. Oh, now we're going to behave. Oh, well. We got a formula. Science class and math mixed together. What did I say about times when we have to do formulas in this class?
It's on the purple spot.
It's on the purple reference table. I have a white one here, but I'll just show you. Again, equations are always written here. You always have them in the same spot. You don't need to memorize them. So right in that box is going to be the formula. That rate of change is the change in value divided by time. So that goes in here. So it's not just change, like they say change in value. So it's a change in whatever is being measured. So if you're at the doctor's office and they're measuring your height, you do it every single year. They measure your height every year since you were a baby. So that is how fast your height has changed. It could be change in your distance. So how many miles you've gone. It could be a change in temperature or a change in pressure divided by time. So change in whatever the question's asking you about divided by time. Then we put this graph, then we put that information on a graph. If you do your height, you can plot your height from the day you were born until today. You could make a graph of that. So graphs allow us to see the relationship easily. Yes. example, if I did a graph like this, doesn't have to be, if you're copying it, doesn't have to be perfect. So it's the years on the bottom, height on the side. Did I spell height right? No, I'm good, right?
Yeah.
You notice a few things. What do you notice about the line on my graph?
It can't stop matching thing.
Okay, it does max out. That's one thing. What do you know? Okay, so you know where I'm going with this. So we've got a really steep line here. Then it slows off again. And another steep line, and then it stops. Yeah. These are your growth spurts. Think of a newborn baby. Any of you who have experienced being around a newborn to like when they're a year and a half, think of how much those kids grow. Like we had that Emmett kid I showed the very like at the beginning, me and my daughter with our friend Emmett. That kid was teeny tiny and now he's like a Buddha baby and he's not even a year old. He weighs more than my kids did when they were 2. Buddha, you know Buddha? Google it.
I got you.
So newborns and babies grow pretty fast. Then their growth kind of tapers off. When is this next growth spurt? Puberty. You guys grow super fast from like, you're probably almost unrecognizable from 7th grade. And then what's going on here? You stop growing, right? I haven't grown since puberty. I haven't got taller since puberty. And then it eventually, like my mom, might go jump a little. She's dropped an inch. She was 5'3" and now she's 5'2". So you can look, you guys already sound like most of you had a good grasp on how you use graphs to measure change. So when the line is steeper, what is that indicating about the change? It's a fast change. When the line is less steep, it's a slower change versus a no change or a negative change. So you guys got the gist of rate of change. I don't want to do all of these questions. I just want to make sure that you know kind of the idea of like what the Regents is going to throw at you. And like I said, if they give you one question, I would be surprised. So here's number 1. The temperature of the water in a container was 60 degrees. The minutes later, 10 minutes later, the water temperature was 35. What is the rate of cooling of the water? So we still go with the same formula. So change in value divided by time. What did it start at? 60. What did it end at? 35. How much did it change and what math do I need to do to figure that out?
Subtraction.
I need to subtract. Now, guys, I know you should be able to subtract, but please don't use your brains. Because if you subtract this and you tell me that the change is 35 degrees, you're gonna get it wrong. And I would hate to get it wrong because you subtracted wrong. This is not 2nd, 3rd, 4th, 5th grade math class. This is 10th grade science. We don't care if you can do math in your head anymore. They only cared back then. So use a calculator. When you do subtract this, it's 25 degrees. So is that the answer? And what do you notice?
It's there.
It's there. They do it to mess with you.
You gotta move it this way, not me.
Well, right, we got yes. So now we have to plug it into the formula. What's the formula?
Something over time.
So it's the change. So it changed 25 degrees Celsius over time. And how much time? They didn't like say this took 10 minutes. So yes, we move. So 25 divided by 10. And yes, again, a lot of you know that, but please don't trust your brain. It's 2.5. Now, again, just like yesterday, I want to talk about the units. I know they give you the units in the answer, but just in case they don't, I want to make sure you know how to do it. Just like yesterday, the top units was degrees Celsius. The bottom units are minutes. Do Celsius divide into minutes nicely and give me a number? Nope. So you just flat out copy those numbers. So degrees Celsius per minute. So they're going to do the questions like that. I heard a few people not sure how to calculate the change. So back in this box, if you did not know, like immediately when I said, what do you do with these two numbers to figure out the difference or figure out how much it changed? Please add a note that says subtract the two numbers. So I definitely heard a few of you not positive about that. So be honest with yourself. Did you know that? If you didn't know it like that, add a note. Those are the types of questions. Now they might give you a graph. Instead of flat out saying it was 60, then it went to 35, you might have to read it off a graph. But it's the same deal. So here we want to know temperature change in degrees per hour between 6 a.m. and noon. So we figure out what it was at 6 a.m. Up and over, that was 30 at 6 a.m. And then at noon, it was just below 50. What do you want to estimate that at?
48.
Let's go 48. So at noon. Again, what do I do to figure out the change? Subtract. So that's a difference of 18. And how long did that take?
6 hours.
How'd you know?
It's 6 a.m. and then
6 a.m. to noon is 6 hours. So 18 degrees Fahrenheit divided by 6 hours is 3 hours per minute. But again, notice they gave you a 6 degrees per hour. They gave you an 18 degrees per hour. Yeah. Sorry. Oh, see, and you don't want to mess that up because that's embarrassing. So they gave you, no, I was right.
Yeah, no, I'm saying you said per minute.
Oh, I see what you're saying. I'm sorry. So yeah, I was right the first time. Don't listen to Colden. Colden, right?
Yeah, cool.
Or listen to Colden's all his words he said.
I got it right. Because actually correcting per minute.
Yeah, no, I just listened to exactly what you're telling me. Yeah, so notice they gave you all the wrong number answers just to throw you off. All right, so that's rate of change. One, now let's talk about the density stuff from yesterday. Grab that little sheet of paper, please. The one we did yesterday. Here, I hand it back, I think. We're not gonna go through all of this because I looked at it. Most of you guys got it. Couple things I do want to talk about. To point out what was the volume of the cubes. What-
Centimeter cube.
What, all of them? Everybody's cubes were 1 centimeter, 1 centimeter cube. Good, they were supposed to be. How did they have, how can you explain them having the same volume? Morgan, you talked a lot. How about the rest of you?
They all have 1 centimeter.
No, you four have talked a lot. How about the rest of you? No, you talked a lot.
I'm with the group too.
Okay, so, Landon, right?
Yeah,
Landon, why did they all have the same volume?
because the length and width and height
Were
the same.
the same. In other words, is there an easier way of saying this?
One time. They're the same size.
They're the same size. That's all I wanted. Did you notice that the two blocks you had were practically identical to each other? Because if you didn't, that was another thing you're supposed to notice.
No,
They should have,
the one was.
it spins better. I'm not gonna ask why you know that. So they should have been the same size. That was the point. So by the way, how did you define volume? Size. Volume is literally the size. There's another way of describing. What other ways did you describe volume? That's the other way of explaining it. Amount of space it takes up. So these were both the same size. but they didn't weigh the same on the scale. How can that be? Density is not a good enough answer. Come on, the rest
One's
of the
more
class.
densely.
No, time, thank you for your participation. Thank you, thank you, thank you. No. Boss, you wanna try this one? What? Wait, what about it? Like, how can it weigh more? Yes, not you. Not only are they closer together, but because they're closer together, and because there's more of them then. I like to relate this to suitcases. My husband and I legit have the identical suitcases. They're identical. Why is his always lighter than mine on vacation? I put more stuff in it, or as somebody said last period, I overpack. I don't think I overpack, I just pack everything I own. He brings 3 pairs of underwear. I mean, that's it, like maybe a pair of socks. So, which one's more dense? My suitcase. How can you explain then? Because clearly you get density. How can you explain density? How packed the molecules are in case of my suitcases, how tightly packed my clothing was inside that suitcase. So I know we're jumping around on this, but the whole moral of the story, density, I want a good definition of it. And you were correct. I don't know what I was about to write. How tightly packed. How tightly packed the molecules are. There was one more moral of the story I wanted to talk about. Do you guys have that paper handy? The one we're writing on right now?
Yeah.
What were your densities? So everybody had a different metal, but what were the densities of your wooden cubes? 0.4. Anybody else have a different number? I heard some 0.3s, 0.4s, and 0.5s. So pretty much all the same. Okay, so everybody's were really close. And I think that came with differences. I think one big difference is, and those of you who are here first period when I did it, I dropped one of the scales on the ground and the pieces went everywhere on yesterday. It was a terrible experience for me, but I think I broke the scale. So one difference is I think the scale was broken. And the other difference is when we're talking about, this literally weighed 0.4 or 0.5 grams. That's nothing. So if it had you had like an eyelash that fell off onto your scale, it was going to change how much this weighed. But basically everybody had the same density for their wooden block. What were your densities for the metal blocks? 2.7, what was yours? 9. What else? Give me your numbers. 7 point something, 8 point something, very different. So why were all the wooden blocks the same? Because they're all wood. Why were the metal blocks different? Different metals. So then here, I got another wooden block.
Oh, that might be a little heavy.
So, what's the density of this wooden block?
Not a lot.
Okay, same thing or a lot. One of those answers is correct.
It doesn't matter.
The density.
Oh, if you cut it in half, it's still gonna be the same density.
How do we figure out the density of this block?
Same thing.
Mass over volume.
The formula.
The formula. Okay, somebody get, you can grab your phone.
Got it. I'm already on calculator.
86.2, that's the mass. I don't think you can put that in your calculator yet. We're gonna 86.2, 86.2.
Alright.
I'm gonna write it. I'm gonna cut this one in half. I'm gonna say 86.2. Now this isn't a cube, so I have to measure all 3 sides or 3 sets of sides. So here's my length, 7. Length of 7. Width is also 7. Height is 3.6. 7 times 7,
176.4. Oh.
everybody get the same thing? Now, those are way bigger than your numbers for this tiny block, right? Because wasn't it, whoops, 0.5 and 1? So these are centimeters cubed, which gave you a density of 0.5 grams per centimeters cubed. Did anybody do the math yet for me here? How can that be? This is like 100 times the size of that little block. That's for sure. We got it.
As long as they're proportional, then they'll be the same, but then the mass and the volume or like the length times.
Yeah.
Will go up the same rate.
You're right. But why is it proportional?
It's still the same stuff
It's
inside.
still the same stuff. This is still wood. As long as it's the same material, it will have the same density. So what happens if I cut this block in half? What's the density of this side versus that side then? They're the same. What about this metal block? What if I cut that little tiny guy in half? It's still going to have the same density. What if I cut my pinky off and compare the density of my pinky to the rest of my body?
I don't know.
Should be the same. I mean, there might be some differences because I guess there might be more bones there than if I cut my ear off, but work with me here. So they all have the same density because they're made out of the same stuff, me. Okay, doesn't matter how big the object is, if it's really big, or if it's really small, or if you cut that object up, it will have the same density. So you, as you hopefully saw on the board, you do have homework today. It is pages 14 and 15, but everybody look at page 14. See how most of page 14 is actually notes? Density, we just defined that. I won't make you write it again, but if you want to, it's how tightly packed matter is. Formula, I won't make you write it because it's on the front page of your reference table. I do, however, want you to write the formula or the two properties of density that we literally just talked about. We just worked through this, but I want to put them in your notes. So here's the two properties. One, the same substance has the same density. Cooper, write this.
I already did it. You wrote that?
You did not.
Yeah.
Oh, you did. And density, sorry. Density does not change. If the material is broken into pieces. You do not have to do the example on that page. So you can cross the example off. So your homework is at the bottom of page 14, questions 1 and 2, and then all of page 15, which is only questions 3 through 8. So you have 8 density questions for homework. The questions are either the fact that the same material will always have the same density, or it's just calculating density. So we're not going like crazy here. That's it if you don't have any questions.